In the previous lessons, we have seen that the calibration process is necessary to ensure that it is possible to obtain a measurement result and the related measurement uncertainty from the readings provided by a measurement system. We have also seen that the result of a calibration is valid under the calibration conditions and at calibration time. However, in practice, we need to know whether the calibration result can also be used at later times as well. This requires carrying out a series of operations known as metrological confirmation, defined by the ISO 10012 standard as the set of operations required to ensure that a measuring instrument complies with the requirements for its intended use. This standard specifies that this set of operations includes calibration, any necessary adjustment and repair and subsequent recalibration, and comparison with the metrological requirements for the intended use. To guarantee the metrological requirements for the intended use, strictly speaking, one should carry out a calibration under the conditions and at the location of use before employing the measuring system. It is clear that this way of proceeding is so expensive as to be impracticable. On the other hand, it cannot be excluded, even if it is unlikely, that the result of the calibration may cease to be valid immediately after the calibration has been carried out. For example, if the instrument is damaged in a way that it is not immediately visible during shipping from the calibration laboratory to the place of use, its metrological characteristics may no longer be suitable for the intended use, even though the calibration results indicate otherwise. Verification that the metrological characteristics are maintained can be carried out in various ways. For example, if you have a measurand that is stable over time, you can measure it before sending the instrument for calibration and measure it again after it returns from calibration. If the two results are metrologically compatible, the metrological characteristics are confirmed. If you do not have a measurand that is stable over time, but you do have an instrument with the same characteristics as the one sent for calibration and which has already been calibrated, you can measure the same measurand with both instruments. If the results are metrologically compatible, the metrological characteristics are confirmed. These procedures are usually referred to as metrological verification. These same procedures can be used to check whether the metrological characteristics have been maintained over time or whether it is necessary to carry out an adjustment and a subsequent recalibration. For example, if a laboratory has several instruments of the same type, such as a dozen calipers or a dozen voltmeters, as is typical in industrial laboratories, it is possible to measure the same measurement with all the instruments. If the results are all metrologically compatible, the characteristics have been maintained for all the instruments, as it is highly unlikely that they would all have drifted in the same way. If one of the instruments is found not to be compatible with the others, it is necessary to proceed with a calibration and, if required, with an adjustment and a new calibration. It is in any case advisable to act before a situation arises in which the instrument, due to some internal drift, no longer meets the metrological requirements demanded by its intended use. In cases where it is possible to make comparisons between different instruments, as in the earlier example, it is sufficient to use the normalized error discussed in one of the previous lessons to assess metrological compatibility. A threshold lower than 1 is set, for example 0.75. If the instrument exceeds this value, it is then calibrated. In this way, action is taken before the characteristics of the instrument no longer meet the required metrological standards. However, there are several cases in which it is not possible to carry out comparisons between a statistically significant number of similar instruments. Even in these cases, it is necessary to establish when a new calibration should be carried out to prevent the instrument from no longer meeting the required standards. The ISO 10012 standard suggests several methods essentially based on the analysis of historical calibration data and their comparison. For example, one can assess the compatibility between the results of successive calibrations by evaluating the normalized error EN and analyzing its trend over time. Let's consider, for instance, the case shown in this figure, where the normalized error shows a slight tendency to increase between one calibration and the next, as indicated by the dashed trend line. From this, it can be assumed that the employed instrument has a slight drift over time, and the interval between two successive calibrations can be increased without risking the instrument operating outside the required metrological specifications. Let's now consider the case shown in this other figure, where the normalized error tends to increase very rapidly between one calibration and the next, and exceeds a warning threshold represented by the suitably chosen red dashed line. It can be inferred that the instrument tends to drift very quickly, and in this case, it is advisable to reduce the period between two successive calibrations. What is shown here is a very simple method. There are others, such as the method considered by the French standard AFNOR FDX 07-014, which takes into account other parameters such as the frequency of use of the instrument, the seriousness of the consequences of failing to meet the required metrological requirements, the cost of calibration, and the tendency of the instrument to drift. The important aspect to consider is that the frequency of calibrations is a critical factor in ensuring the fulfillment of the required metrological requirements for the intended use, and must be established on the basis of objective technical criteria. To summarize, we have introduced the concept of metrological confirmation and have seen that calibration is an essential element to ensure the fulfillment of the metrological requirements needed for the intended use of the measurement system. But it is not sufficient. Metrological verification operations are also necessary, and it is essential that the frequency with which calibrations are carried out is determined on the basis of objective criteria.